In this video, we're going to be discussing this here question on imaginary numbers and complex numbers in Algebra 1. The problem statement says, compute the quotient 30 minus 50i over 3 minus 5i. So this question requires a little bit of knowledge, some basic knowledge, about imaginary and complex numbers. So before we get into solving this question, I'm just going to give a very brief overview of what an imaginary number and a complex number is. So basically, when we have an imaginary number, this is denoted by I. Imaginary number itself is I. That's the base value here. And it's important to note that I equals the square root of negative 1. That's basically the main definition of I. That's just a variable or number we use to denote the square root of a negative number. So like I would help us solve problems like the square root of negative 36 or the square root of negative 49, where the answers to those problems are considered imaginary. Where, for example, square root of negative 36 would be some multiple of I. And essentially, another important fact to know about imaginary numbers is that I squared is negative 1. It's also important to know the other powers of I, but just for the purposes of this video, it's important to know that I squared equals negative 1. And you can see this easily, because we know that I equals square root of negative 1. If we square square root, you're just going to get the thing under the radical, which in this case is negative 1. So that's the basic definition of an imaginary number. A complex number isn't really that advanced. All it is just a number with a real part, such as this 30 up here, and an imaginary part, such as the minus 50i. So a complex number is any combination of a real and an imaginary number. Another example is 6 plus 2i, or 8 minus 6i. These are both complex numbers here. Alright, so now with that little bit of background, let's go ahead and get on to this problem. This is basically just a problem of complex number arithmetic. We're dividing a complex number by a complex number. So to solve this problem, we're going to need to use and utilize what's called a conjugate. So a conjugate, in this definition, is the conjugate of a plus bi complex number is a minus bi. So it's basically, you flip the sign that's separating the real part from the complex part. That's all it is. A plus bi, a minus bi. 3 minus 5i becomes 3 plus 5i. 6 plus 2i equals 6 minus 2i. So it's all about flipping that sign there. It's pretty simple. Alright, so that's what a conjugate is. So how we're going to use this to solve this problem is, important fact to remember is when you multiply a conjugate of a real number by the original real number itself, you're always going to get a real number. So if you have, here is the full rule stated, a plus bi, that's our complex original number, multiplied by the conjugate of that, a minus bi, you're always going to get real numbers out of that product. And that's a very important fact for solving these sorts of problems that we're going to want to use. Now here, we're going to want to first get our denominator rationalized. And that means we want to get our denominator so that it's a positive integer. We don't like this messy complex number stuff. We want it to be a positive integer that we know how to deal with. So to do that, well, we know how to get a real number out of a complex number. Just multiply it by the conjugate. So we're going to multiply top and bottom, because that's what we have to do, top and bottom of this fraction by 3 plus 5i. That's the conjugate of 3 minus 5i. So if we do that, what we're going to have, we're going to write our original fraction here first, then times 3 plus 5i on top, and 3 plus 5i on the bottom. Okay, from there, we can just multiply straight across. We get two binomial complex numbers here, 30 minus 5i times 3 plus 5i, over 3 minus 5i times 3 plus 5i. Okay, So we've got our fraction worked out here. From here, all we have to do is use the distributive property to distribute through this product. Got a different color here, easier to see. So we're going to start with the top. We've got distributive property, first term. That's going to be 90. Then we're going to have outer term. That's going to be 150i. Remember the I there. Then inner term, minus 15i. And then last term, plus 25i squared. Got to make sure we've got that squared in there because we got two i's. So, we have some like terms here. We can combine like terms just like we would with any other algebra problem. We're going to combine those i's. We're going to get 125i as, not 135i, sorry. Plus 135i plus 25i squared. Okay. So from there, all we have to do is use the rule that I squared equals -1. So we do 25 times -1 equals -25. So that's all we have to do there. And eventually, if we multiply all the way through, combine like terms, on the top we'll end up with 90 minus 250i squared. Okay. Now, we've got the numerator sorted out. That's the numerator up here. We're going to work and use the same process on the denominator. We multiply through using the distributive property. The first term is going to be 9. The outer term is going to be plus 15i. The inner term is going to be minus 15i. And again, we've got our plus 25, or minus 25i squared. Yes, additionally, I wrote this incorrectly. This should be minus. We got a minus and a plus there. Okay, so we've got 15i minus 15i. This is going to subtract out. We've got 0 here in this portion instead. So 15i minus 15i is 0. We're simply left with 9 minus 25i squared. So that's our denominator. So since I squared equals 1, we end up with 9 plus 25. Because 25 times negative 25 is going to turn it positive, which means 9 plus 25, which means we're going to end up with 34 on the denominator. So, we can now begin to simplify this fraction and get into a more familiar form. We've got our I squared here. I squared is -1. Turns this negative 250 to positive 250. So that gives us 90 plus 250 is 340. So we have 340 over 34, which was our computed denominator down here. All right. So then all we have to do is simplify this really easy to understand fraction. We've got 340 over 34. That's simply 10. All right, that is it for solving this problem. That's pretty much all there is to it. All you have to do here is multiply the denominator of this complex number fraction by the conjugate of that denominator, since that will always yield a real number. Once you get that, you're going to get this product that you then have to distribute, probably the hardest part, and then you go through that, and you end up with imaginary numbers end up canceling, and you end up with a much simpler and much easier to understand fraction here that you can then simplify. Alright, that's the general point behind this video on simplifying complex number fractions. Stay tuned for more algebra videos on complex numbers and imaginary numbers.